Hello everyone and welcome back. So throughout previous 6-7 videos we learn how to decompose a rational function under case 1. Now what was case 1 again? Well, we have a rational function, a polynomial over a polynomial, but the denominator contains the polynomial with the highest degree, right? That was case 1. So even though we had a lot of sub cases under case 1, all the problems that we had always had the denominator with the highest degree polynomial, right? Okay, so just like this rational function. Now how about the opposite? How about if we have a rational function like this? Now as you can see in the numerator we have the polynomial with the highest degree, right? Not the denominator. So how do we approach to this problem? All right. So the approach that we take is a little bit different from case 1, okay? At least in the very first step. So the very first step is different between case 1 and case 2, okay? Alright, so I'm going to explain this to you using an example, using an equivalent form of this fraction but with numbers. Now look at this fraction, 17 over 5. Now it's a sort of same scenario, right? In the numerator we have the value with we have the highest value out of both numerator and denominator, right? 17 is greater than 5, so it's sort of equivalent to this scenario. Now let's take 17 over 5. Now I can write 17 over 5 as 3 plus 2 over 5. Now how come? How did I write 17 over 5 like this? Let me show you. So what I'm going to do is I'm going to divide 17 by 5. I'm going to use lone division. So usually on the numerator, what's on the numerator or what's inside here, we call it the dividend. Okay, the names are important here. And the denominator divisor. So the what's in outside is called divisor. So 5 is the divisor. Okay, so for 17, how many 5s? 3, right? 3 times 5 is 15. Now subtract 17 minus 15 is 2, so you cannot do anything furthermore, so that's it, right? The lone division. Now this 3, what we get here, we call it the quotient, okay? Quotient. And this 2, what's left here, we call it the remainder. Remainder. Now the names are important, okay? So let's put them there. Alright, now can you see the relationship? So the 3 that I have here is actually the quotient. The 2 that I have here is actually the remainder. So any fraction that look like this, an improper fraction, we can write it like, okay, write it as quotient, let's say Q, plus remainder over divisor. So that's the formula. Now this is a very important formula. So quotient 3 and the remainder was 2. As you can see, we can write it as quotient plus remainder over divisor, a fraction that has a fraction where the numerator has the larger value. Okay, so we can decompose it like that. So this is an important formula. All right, now the other thing that we must focus on, or we must notice, now if you look at when we decompose 17 over 5, this is a mess, so let me write it again. We wrote it as 3 plus 2 over 5. Now we have two fractions here. Of course we have this troublesome fraction here, but once we decompose it, I mean once we do the lone division, we get another fraction here. Now look at that fraction. That's a proper fraction. In the numerator, in the denominator you have the value with the larger, you have the number with the larger value, right? So now it's a proper fraction. So actually what you get always here, the remainder over divisor will be a proper fraction, okay? Will be a case 1 scenario. Okay, so what's the point in all of this? So how do you decompose a rational function like this when you have polynomials? So it's very identical to what we did here. What we do here, the first step, the very first step will be, instead of lone division, now we use polynomial lone division. Okay, just like here we use polynomial lone division for polynomials, and then we find the quotient, then we find the remainder. Of course you know divisor is the denominator. Then you write down this formula, okay, Q plus R over divisor. Now you will get another fraction, R over divisor. So this r over divisor will be a fraction that belongs to case 1. Okay, now you decompose that r over divisor fraction using case 1 strategies again. So there are two steps. Okay, so first step and second step. First step is polynomial lone division. Do the polynomial lone division, get the format q plus r over divisor. Once you got that, then you will get another fraction here, r over divisor. Okay, use case 1 strategies there to decompose it furthermore. Okay, so let me show you an example. Okay, all right, so from here on, what I'm gonna do in this video is I'm gonna review polynomial lone division. If you're really comfortable with polynomial lone division, you can skip this video, okay, and go to the examples in the next video straight. But I suggest you to wait and review polynomial lone division. So let's take a rational function, x square minus 3x minus 10 over x plus 1. Okay, so here this is case 2 scenario, right? Okay, so the first step is use polynomial lone division. So let's do that. X square minus 3x minus 10 should be divided by x plus 1. So here the divisor is x plus 1. Okay, all right, so to do the polynomial lone division, we compare first term of the dividend to the first term of the divisor. So how can I create the first term of dividend by the first term of divisor? So x square need to be constructed using x. So if we multiply x by x, we get x square. So we multiply by another x. Now once you find this, re-multiply divisor by that x. So x times x is x square, x times 1 is x. Now here's the important thing. This is the step that you can do lots of mistakes. Now you do subtraction. Okay, make sure you do the subtraction very carefully. Here I got plus because x times x is plus x, right? Okay, so do the subtraction very carefully. X square cancel out. Minus 3x subtract plus x is actually minus 3x minus x is minus 4x. Here there's nothing to subtract from negative 10, so that negative 10 comes down for free. Okay, all right, now compare the first term. Negative 4x with x. How can you create negative 4x out of x? Multiply by negative 4. Negative 4, okay, so now re-multiply by negative 4. Negative 4 times x is negative 4. Let me clear up this mess. Negative 4x, negative 4 times 1 is negative 4. Now subtract, be careful. So negative 4x subtract negative 4x will cancel out, okay? Alright, so be careful with these steps. Okay, so this will cancel out. You can do it like I did here, okay, to make sure you avoid mistakes. Negative 10 minus 4x will be plus negative 6. Alright, so now first term. So here the only term is negative 6 to x. Now negative 6 is a polynomial. Actually it's a constant polynomial with 0 degree. But here it's a first degree polynomial. So for the first time of this process, we have something here which is less than x plus 1 in the polynomial sense. So now we stop. So where do we stop lone division, polynomial lone division? Whenever you got something here where it's smaller than the divisor, okay, just like in the number scenario, okay. All right, so now let's get the details. So what are the details we need? We need q, the quotient. What is the quotient? X minus 4. We need the remainder. What is the remainder? Negative 6. We need divisor. What is the divisor? X plus 1. That's all what we need. So the formula is q plus r over d. So q is x minus 4 plus remainder is negative 6 over divisor is x plus 1. See? Okay, so this is the initial decomposition, the first step. Now what you have to do from here on is, here you have another fraction which is a case 1 scenario. Now do the decomposition for this fraction again. Now here actually you don't need to do anything in this specific example because we only have a one factor. It's already in its simplest format. It's already kind of decomposed, okay? So you don't have to do anything here. Alright, because we don't have any distinct linear factors or repeated factors or irreducible factors. I mean several factors. So we can stop here, okay? This is, I mean, the lamest example you can take, the easiest one you can take, okay? Alright, so I just want you to show the first step. Alright, but keep in mind, you will see in the next video that once you come here, you will have a case 1 fraction and you will do decomposition furthermore. You will see in the next videos. Alright, so I want to finish off this video with a specific polynomial lone division example, okay, because there's something that I need to review. I think you might have forgotten this. So 2x cubed plus 5x square plus 4 over, let's see, x square plus 2. All right, so what's so special about this example? Yes, this is special when it comes to the polynomial lone division, so I will show you. So the device is x square plus 2. Now look at this polynomial. So we have a 6th degree polynomial, but we are missing 4th degree term, 5th degree term, and 1st degree term in this polynomial, right? So it's crucial in polynomial lone division you represent them even though they are missing. So there's no 5th degree term, but I would write 0 times x to the power. When you multiply something by 0, it doesn't exist, right? I mean, it's 0, so it doesn't exist here, but it's good to pretend that it's there. 0x to the 4, even though it's not there, 2x cubed, 5x square, and 0x plus 4. Alright, so let's do the polynomial lone division. So x6 to x square. So you need to multiply by x to the 4 to create x6 out of x square, right? Now re-multiply. x6 2 times x to the 4 is 2x to the 4. So write it under x to the 4 term. So there are nothing. Okay? Alright, so that's crucial. Alright, so now subtract. x6 cancel out. 0x to the 5, 0x to the 5, there's nothing. So 0x to the 4 minus 2x to the 4 is negative 2x to the 4. Here 2x cube comes down for free, 5x square comes down for free, 0x comes down for free, 4 comes down for free. Alright, so now the first term. Negative 2x4 to the x square, well, you have to multiply by negative 2x square, right? Negative 2x square times x square is negative 2x to the 4. So here negative 2x to the 4. When you multiply negative 2x to the 4 by 2, it's what? Negative 4x to the 4. There's no x cube term. Okay, so mark that. Alright. Okay, I need space. Alright. So when you subtract, you get 2x cubed. 2x cubed minus 0 is gone. This term cancels out. 5x square minus 4x square is actually, this is plus 9x square, right? Plus 0x plus 4. Alright, x cube and x square. So to create 2x cube out of x square, you have to multiply by 2x. So let's multiply. 2x times x square is 2x cube. 2x times 2 is 4x. So here nothing, plus 4x. Okay. Now subtract. Be careful, okay? 2x cube cancel out. 9x square minus nothing is 9x square. 0 minus 4x is minus 4x, and this 4 comes for free. Now the first term, 9x square and x square, so you have to multiply by 9. 9 times x square is 9x square. 9 times 2 is 18. Here nothing, plus 18. Okay, so if you subtract, you get minus 4x. 4 minus 18 is what? Negative 14. Okay. Alright. So now let's compare. Alright. So now first term negative 4x and x square. So now for the first time we have something here. This is a first degree polynomial and device is a second degree polynomial. So divisor is now larger than what we have here, right? So we stop here. Alright, so then let's grab the details. So we need q, the remainder, x to the 4 minus 2x square plus 2x plus 9. And the remainder is negative 4x minus 14. And divisor, of course, is x square plus 2. Alright, so then what is the decomposition? It's going to be q. It's going to be q plus r over d, right? Alright, the initial step. So what is q? X square, x to the 4 minus 2x square plus 2x minus 9. X square, x to the 4 minus 2x square plus 2x plus 9. Plus the remainder is, oh come on, there's no space. So let me write it again. X to the 4 minus 2x square plus 2x plus 9, that's q. Plus remainder is negative 4x minus 14. Device is x square plus 2. Alright, so this is the decomposition. Now if you look at here, this fraction In the numerator, we have a first degree polynomial. In the denominator, we have a second degree polynomial. So now denominator is large. So this is a case 1 fraction. So we would do case 1 strategies to decompose it furthermore. That's what you would do, okay? But here you don't have to do anything because we only have a one factor. X square plus 2, you cannot decompose it furthermore. It's irreducible, but still there's only one factor. So it's in its most simplest format, okay? So you don't need any decomposition furthermore, it's already decomposed, okay? So you don't have to do anything from here. But you will see next video that you get problems where you have several factors here, so you do case 1 strategies again. But the big idea is when you have a case 2 fraction, that means when the numerator is a larger polynomial than the denominator, what you do is first do polynomial lone division, find quotient, find remainder. You already know divisor, write this format, and then from here on decompose R over D fraction using case 1 strategies, okay, which we will see in the next video. All right, thank you for watching this video. I'll see you in the next one. Bye bye.